Hi, crawlers. Welcome back. Welcome back to another session of Hefe's Funhouse. We're doing another video on 410, the antiderivatives. We're going to look at the formal notation for the antiderivative, and it's called the indefinite integral. Later on, we'll do definite integrals, but that's in chapter 5. So if f of x equals f prime of x, cap big F prime, we're going to use the notation, this squiggly line right here, and then f of x dx equals big F of x plus c. This sign right here, the squiggly line, you actually can see it on violins and guitars. We call it the integral sign. It looks like a very tall, thin S. Okay? Sometimes when you're doing it in like a word processor, like Microsoft Word, it doesn't do it as well. We call this part here, this is called the integrand. And x is the variable of integration. And the way you tell what the variable of integration is off of this letter right here. That will tell you what you're integrating with respect to. So let's change color on that, make it nice and light that shows up. It's matching up with that. Okay? So integral symbol, integrand, variable of integration. 3 things to know. And we say the act of finding the antiderivative of f, the act of finding this, or doing this integral here, doing the integral is called integrating. So we call it integrating f. So the biggest one, we were looking at this a lot. If we took the derivative of x to the n plus 1 over n plus 1, we would bring the power down. So n plus 1 comes down. This power drops by 1 when we take the derivative. And notice how n plus 1 and on the outside and the n plus 1 and bottom are going to cancel. We just end up with x to the n. So if this is the derivative, the way we do is we integrate backwards by adding the integral symbol and dx on both of these. In fact, you'll see this, what I'm doing right now, later on in chapter 5. But we end up generating the power rule this way. The power rule is the integral of x to the n dx equals, like if we're working backwards, we're going from here to here because that was the derivative. So the integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c. The way I think about it and the way I memorize it, and I even say it in my head when I'm doing it, I go up a power and then divide by the new power. So if I had x to the 6th, I go up a power and I divide by the power. Okay? We'll have a bunch of examples with this, but that's how I tend to do the power rule. There's a whole bunch of general integrals that they have in the book, and you can show, like, the integral notation is consistent throughout, and you're literally going, just this is our thing that what we're going to integrate, and this has got to be what the original function was. So I recommend, and you should, by the time we get to the test, have all of these memorized. And their integrals. You should know all this stuff. Okay? Below that line, hopefully you can memorize these. These are a little harder, but they show up less often. And I'm going to be honest, when you get to Calculus 2, you're going to learn a method that will help you find these without having to memorize the formula. I don't have these memorized, but until you get there, like, it's helpful to have them memorized, to look them up. Okay. And then also, like, remember when we were doing derivatives, if we took the derivative of several things, that meant we could do the derivative of each separately. That applies to doing integrals, because integrals are doing derivatives going backwards. So the integral of f of x plus g of x, I can technically separate it into two integrals. And then each of these becomes the f and the g. Okay. This is the notation they gave in the book. I'm going with the one they had. Also keep in mind that if we had a coefficient on a derivative, we can pull the coefficient outside the derivative. And that makes the same happen on integration. Integration does the same stuff as derivatives, just goes backwards. So if I can take k out on, or the coefficient out on a derivative, I can take k out. I can put k outside the integral here. In fact, let's add that in. I didn't write it in, but I think it's worth seeing. And I'm going to show this notation too. This is the integral of f of x dx plus the integral of g of x dx. I think the book skipped a step there, and I don't think that's a good idea. Okay. So let's verify the following integrals by taking the derivative. I am claiming that the integral of 3x plus e to the x, or the antiderivative of 3x plus e to the x, is 3/2 x squared plus e to the x plus c. And we can always verify this. This is a helpful thing to think about, because when you're doing integrals, if you're not sure if you got the right answer, you can always take the derivative. We're going to take the derivative of this, so we'll take the derivative of this right here. Oh, I'm not on eraser or highlighter mode. I like highlighter mode. We're going to take the derivative of that right there. Remember, we can apply it to each of them individually. So that's what I do here. And then I take the derivative. The derivative, the 3/2 can come out. And then I take the derivative of x squared. And I have 3/2 times 2x. And then the derivative of ex is just ex, e to the x. And the derivative of a constant is 0. And when I clean up the fraction, I got 3x plus e to the x. That was what I had up there, so I did verify it. That's worth knowing. Know this. Oh, I already got yellow there. Let's go with blue. You can confirm your indefinite integral solution by taking the derivative. And matching it to the, do you guys remember what this thing was called? What this part was called right here? That part was called the integrand, matching it to the integrand. Okay. Let's give you guys one to try. Pause the video and confirm, verify that the derivative or the integral or the antiderivative of x e to the x is x e to the x minus e to the x plus c. All right, I'll assume you did. We're going to take the derivative of that thing on the left, remember, or on the right. Remember, you got to do a product rule. So like this part, this matched up to all of this right here. Product rule. No, I didn't do that yet. Shit. This one's going there. Next step, I do it. That is matching up to those. And I highlighted it in pink. I used a different font color, so that shows up. Notice that I have e to the x here and minus e to the x here. So when I subtract, they cancel. And I just get x e to the x, which is what we had. Oh, wrong button. What we had up here in the first place. Okay. So now I want you to try evaluating the following. We're not going to verify. Just try to calculate what the antiderivative is. Doing our indefinite integral. I recommend you stretch it out, putting an integral on each until you're comfortable in doing it faster. Eventually, you'll be able to just pop it all out at once, but you should practice doing it like this because this is what's really happening. Then you can pull the coefficients out front. Here, notice I didn't pull a coefficient out. I actually went from 2 to 2x to the 0 because it makes it a little easier to see what I got to do. When I integrate, I go up a power, and then I divide by the power. Okay? So this goes up to a 4, then I divide by the 4. This goes up to a 3, and then I divide by the 3. Those look like a bunch of question marks with a highlighter. That looks crazy. X goes up to a 2, and I divide by 2. I got to put a 1 out front, even though I had 1. We didn't see it, but now that we're dividing by 2, it becomes a 1/2. And then this goes up to 1, and we divide by 1, but that doesn't change the value, so I just left it as 2x. And don't forget your constant of integration. Okay? All right, let's try another one. We're going to integrate. Our numerator is 4x squared minus 2 times the 5th root of x. The denominator is x. So, I recommend when you're trying to do this, split it up. You can never break up the denominator like that, but if the numerator's got a plus or a minus, we can split this up. Notice this now cleans up. This becomes 4x, because the x squared divided by x gives me an x. Remember on this, when you have like x to the m over x to the n, it becomes x to the m minus n. That's what I did here. I did 1/5 the top one minus the bottom one. I have an exponent of 1 down there that I don't see. And so 1/5 minus 1 is negative 4/5. I haven't actually integrated yet. So when I split up the integral into 2 parts, I even pulled the coefficients out. Now, remember, when you integrate, you go up a power, divide by the new power, n plus 1. Okay? That applies even to fractions. Okay? So we're going to apply that to both of them. So the x goes up to x squared. We divide by the 2. The x to the negative 4/5, what I'm doing is to go up a power, I'm adding 1. Negative 4/5 plus 1, though, is 1/5. And then I'm going to divide by 1/5. So that's what I showed. Dividing by 1/5, though, is the same as multiplying by 5. So rather than dividing by 1/5 there, I'm going to make it times multiplying by 5. Here, I already distributed the 4 times the 1/2 to get the 2. And now here, all I did was move that up to make the 5. Now I'm going to distribute that. I get 2x squared minus 10 x to the 1/5, but x to the 1/5 is the 5th root of x plus c. All right, here's another one to try. We're going to integrate sine x times cotangent x. Pause the video and see if you can figure out what to do. All right, so we don't have, like, our table up there doesn't have sine x, cotangent x, does it? So we got to stop and think, what could we do? What we're going to do, let's break up cotangent x into cosine x and sine x. And now we'll see that sine x and cosine x cancel out. And so this actually becomes the integral of, I wrote the wrong thing there, so let's just change this, which probably means the rest of it's wrong. That should be cosine x there. And if I end up with cosine x, going backwards, the derivative of sine x gives me cosine x. So that's what the integral's got to be. If you're integrating cosine x, this is the tricky one. This is honestly a tricky one to remember. If you're integrating cosine x, I'm sorry, sine x, the derivative of cosine x is negative sine x. I don't have a negative sine x here, so what I could do is I can introduce 2 negatives. I can make it a negative sine x. And then a dx. Okay? Then this part, oh shit. This part integrates to cosine x. And what I end up with would be negative cosine x. Because this part turns into cosine, and I still have the negative out front. So that one can be a little tricky. Be alert on that one. That's one of the tricky ones. Any of the trig functions that have the integration with the, like, when the derivative is negative, the trig functions that have a negative derivative, all the ones that start with c, remember the ones that start with c have a negative? That same process shows up if the outcome of integration has a c on it. And I got one more video. Pause that right there.